Hello there everyone, and welcome to my virtual science class. This is Teacher I, and I'll be your teacher for third quarter for the topic Charges and the Different Charging Process. Our learning objective for today is to describe the different types of charging process. Specifically, learners are expected to A. Identify the different types of charges, B. Describe how objects can be charged in different ways, and C. Appreciate how energy works to make the world a better place to stay. Before we start, I'm going to show you random pictures and you are going to guess what the word or the term is. You have here the first clue. It is a three-letter word. The second letter of the word is U. Can you guess the word? Very good. The correct answer is sun. The sun is the star at the center of the solar system. It is nearly perfect sphere of hot plasma heated to incandescence by nuclear fusion reactions in its core. It radiates energy mainly as visible light and infrared radiation. It is by far the most important source of energy for life on Earth to exist. For the second picture, we have here a six-letter word. Can you guess the word? Correct. We have the word energy. Energy in physics is defined as the capacity for doing work. It may exist as potential, kinetic, thermal, electrical, chemical, nuclear, or other various forms. The third word consists of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 letters. We have first picture, second picture, and the third picture. Very good. The correct answer is electricity. Electricity is the set of physical phenomena associated with the presence and motion of matter that has a property of electric charge. Electricity is related to magnetism, since both being part of the phenomenon of electromagnetism. The topic of electromagnetism will be further discussed later in your higher physics. Electricity is one of the most common energies which you encounter in everyday life. You must be familiar with this energy since it is the energy required to operate appliances, gadgets, machines, and many more. In other words, electricity is a form of energy and this energy makes our appliances work. Aside from these man-made devices, it is also present in nature demonstrated by lightning and of course motion of organisms. However, in spite of this familiar existence of electricity, many people do not know that it actually originates from the motion of charges. All of us here in the world is made up of atoms. Atoms, in turn, are made up of even smaller building blocks. This is also known as the subatomic particles. We have the proton, electron, and neutron. Here is a structure of an atom. Take a look at the illustration. In the illustration, protons, represented with color blue, and neutrons, represented with color green, can be found inside the nucleus, while the electrons, yellow, can be found outside. These are the three subatomic particles of atom. Again, we have proton, neutron, and electron. Protons are said to be positively charged, neutrons are the neutral one or no charge at all, and we have electrons which are negatively charged and is only the moving part of an atom. And remember that they play a very vital role when it comes to charging. Now, have you ever tried or experienced when you are watching television and you get closer to the screen? Yes, you observe that some of your hair are extending towards the screen of your television. Or when you rub a balloon against your hair, you will notice that some of your hair strands cling on the surface of that balloon. That is not magic. That's what we call static electricity. What do you mean by static electricity? Static electricity refers to the buildup of electrical charge on the surface of an object. It is called static because the charges remain in one area rather than moving or flowing to another area. Static electricity is what we know as electric charges at rest. The charge remains until it is able to move away by means of electric current or electrical discharge. There are several ways on how to charge an object, but today we will focus only on three types of charging process, namely charging by friction, charging by induction, and charging by conduction. Now let's have charging by friction. Charging by friction refers to the transfer of electrons from one uncharged object to another by rubbing the two objects together. I have here a short video showing how friction works on an object. When you rub the balloon across your hair in one direction, you may find that your hair was attracted to the balloon. Or when you rubbed the two balloons across your hair and brought them near each other, the balloons repel each other. It is because your hair and the balloons become electrically charged. Now let's watch a short video showing how the two balloons react after one being charged and how the balloon reacts with different charged objects.
Oh, hi. Rub a balloon on your hair and bring it near another balloon hanging by a string. There's an invisible field pushing the two balloons apart. When you rub the balloon on your hair, you're transferring electrons from your hair onto the surface of the balloon. Now, the balloon's made of rubber. Electrons don't flow through it the way they do through a metal wire. Instead, they stay on the surface of the rubber. We use the word static electricity, which means electricity that stays. Now, different materials have different properties. Here's a stiff rubber rod and a piece of fur. It's like rubbing a rubber balloon on my hair. It also will push the balloon away. But watch what happens when I use the same piece of fur and this glass rod. It pulls the balloon toward it. So in the first case, we say they have like charges, like static charges, so they repel. In this case, they have opposite static charges.
The difference in the number of protons and electrons determines an object's electric charge. The two types of charges are called positive and negative. Negatively charged objects have more electrons than protons, while positively charged objects have fewer electrons than protons. When you rub the balloon on your hair, some of the electrons from your hair are transferred to the balloon. This means that your hair lost some electrons, thus becomes positively charged, while the balloon that gains electrons becomes negatively charged. This process involved is called charging by friction. It is also important to note that during the charging process, ideally, the number of charge lost by your hair is equal to the number of charge gained by the object. This is generally true in any charging process. The idea is known as law of conservation of charge. It states that charges cannot be created or destroyed, but can be transferred from one object to another. You must have observed that your hair was drawn towards the balloon as if being pulled by an invisible force. This force is called electric force, and it acts on charges. There are two kinds of electric forces which arise from the fact that there are also two kinds of electrical charges. The interaction between the charges are summarized in a law, and this law is called electrostatic law. It states that like charges repel and like charges attract. Positive and positive repel. Negative and negative repel. But positive and negative attract. The second process is called charging by induction. This refers to the method used to charge an object without actually touching the object to any other charged object. An understanding of charging by induction requires an understanding of the nature of conductor and understanding of the polarization. Figure 1 shows the normal arrangement of the charges of the can. Figure 2 shows that when the charged balloon was placed near the neutral can, the charges in the can were rearranged in such a way that the negative charges moved toward the edge of the can that was farther from the balloon. As a result, the portion of the can closest to the negatively charged balloon will have an excess of positive charge. Likewise, the portion farthest from the balloon will have a negative charge. But the overall charge of the can will be neutral. Although the total charge on the can will be zero, the opposite sides will have an induced charge, meaning to say, a charge produced by charging two objects without actual contact. The process of removing excess charges on an object is called discharging. When discharging is done, by means of providing a path between the charged object and the ground, the process may be referred to as grounding. A ground can be any object that can serve as an unlimited source of electrons so that it will be capable of removing or transferring electrons from or to a charged object in order to neutralize that object. Grounding is necessary in electrical devices and equipment since it can prevent the buildup of excess charges when it is not needed. By touching the can, a path was provided for the charges to be transferred. This is an example of grounding. Ideally, the can will be charged. The hand provided a path for the negative charges to move away from the can. Thus, when the hand was removed, the can was left with a net charge. The can has acquired a net positive charge. The charging process used in this activity is called charging by induction. It is where an object can be charged without actual contact to any other charged object. The last one is called charging by conduction. Charging by conduction is almost the same with induction. It's just that it involves the contact of a charged object to a neutral object. Hence, when an uncharged conductor is brought in contact with a charged conductor, charge is shared between the two conductors and hence the uncharged conductor gets charge. The behavior of a charged material depends on its ability to allow charges to flow. A material that permits charges to flow freely is a good electrical conductor. In contrast, insulators are materials that hinder the free flow of charges. Examples of materials that are good conductors are metals such as gold, copper, iron, silver, aluminum, and steel. Examples of materials that are good insulators are glass, plastics, ceramics, papers, woods, fabrics, rubbers, and foams. One of the best examples of product we observe at home is this one. An aluminum or copper wire is being wrapped in a rubber or plastic that serves as an insulator. And to make it safer, another thicker insulator is used to hold everything into one. Another examples of materials most farmhouses have are sod or sickle and atsa or wooden axe. A sod is a farm tool in which the handle is made of wood or melted plastic materials used to harvest the mature rice stalks. On the other hand, a wooden axe or atsa, it is a piece of farm tool with a wooden handle used to break the mature coconut fruit and to chop or cut large piece of wood. how about you guys? Do you have in your mind another examples? Alright, very good. And that's all about charges and the different charging process. Before we proceed to the assessment part, let's have a recap of what we just discussed. All you have to do is to supply the correct answer. Are you ready? There are two types of electric charge, positive and negative. Like charges repel and like charges attract. There are three types of charging processes. Charging by friction is done by rubbing two objects at the same time. Charging by induction is done without actual contact to any other charged object. Charging by conduction involves the contact of a charged object to a neutral object. Any questions? Now I want you to get your science notebook and you are going to answer the following questions. The assessment is composed of two parts. Part A is multiple choice. Each question will take 20 seconds to answer. Part B is an essay. A rubric is given as the basis for your score. Are you ready? Here we go. And that's all for our virtual class for today. For comments and suggestions, feel free to reach the comment section or inbox me directly. This has been Teacher I. Thank you and God bless.